The roots of the quadratic equation 3x squared minus 5x plus 2 equals 0 are x1 and x2. Without solving the equation, find 1 over x1 plus 1 over x2. So to start with, let's just manipulate this fraction. To add these fractions together, we need a common denominator. So we're going to have x2 over x1, x2 plus x1 over x1, x2. Now we can add these fractions and we get x1 plus x2 over x1 times x2. Hopefully you recognize that this thing in the numerator of the fraction is the sum of the roots and the denominator is the product of the roots. And we know for any quadratic equation, x1 plus x2, the sum of the roots, is equal to minus b over a, which in this case is going to be 5 over 3. And we know that the product of the roots for any quadratic equation is equal to c over a, which in this case is going to be 2/3. Substituting those into our fraction over here, we have 5/3 over 2/3, which simplifies down to 5 over 2. So we've worked this out without actually needing to find the roots themselves. Let's now look at the next problem. x1 squared plus x2 squared. So we're going to do a similar thing. We're going to rearrange this in a way that we can use the sum and the product of the roots. But how can we do that? It isn't immediately obvious how this can be simplified. What we're actually going to do is we're going to rely on the fact that x1 plus x2 all squared is equal to x1 squared plus 2x1 x2 plus x2 squared. Because this is similar to what we have, it just has an extra term. What that means is that x1 squared plus x2 squared, the bits that we have, is equal to x1 plus x2 all squared minus 2 lots of x1, x2. Now notice that we have the sum of the roots and the product of the roots, so we can now substitute in. From above, we know that the sum of the roots is 5 over 3, and we know that the product of the roots was 2 over 3. Expanding this out, we have 25 over 9 minus 4/3. 25 over 9 minus, put this over 9, so it's going to be 12 over 9, which gives us 13/9 as our final answer. Two over x1 cubed plus 2 over x2 cubed. So we're going to do a similar approach here to find this. First of all, we're going to combine these two fractions. So we're going to end up with 2x2 cubed plus 2x1 cubed all over x1 cubed x2 cubed, which we can factorize and simplify to 2 lots of x1 cubed plus x2 cubed over x1 times by x2 all cubed. On the bottom we now have the product of the roots, but on the top we don't quite have the sum of the roots, we have the sum of the cubes. So we're going to have to do a similar trick to what we did in the last one. It's a little bit more complicated, because this time, instead of squared, we've got to do cubes. So let's think about what we would get if we did x1 plus x2 cubed. We're going to use binomial expansion to do this. Binomial expansion, we're going to have 1, 3, 3, 1. We're going to have x1 cubed, x1 squared, x1 and 1, x2, x2 squared, and x2 cubed, which means that x1 plus x2 all cubed is equal to x1 cubed plus 3x1 squared x2 plus 3x1 x2 squared plus x2 cubed. And here we have the x1 cubed and the x2 cubed. So what that now means is we can substitute into here for the rest of it, which is x1 plus x2 all cubed, that's the sum, minus 3 lots of x1 squared x2 minus 3 lots of x1 x2 squared. And all of that is over x1 x2 cubed. So that is relying on the fact that this is equal to x1 cubed plus x2 cubed, and taking this away from both sides, I can make a substitution in. Now that I have that, I can, well, I've got a sum here and a product here, but these ones don't quite work. I'm going to factorize them out a little bit further. So I've got 2 lots of x1 plus x2 cubed minus 3 lots of, I'm going to factorize out an x1, because I can factorize x1 from both, and an x2. And then inside the bracket, I get left with x1 plus x2. Think about expanding this, and it would get me back to here. Factorize out the minus 3, the 1x1 that's in both of them, and the 1x2 that's in both of them. All over x1, x2 cubed. And now each of these is either a sum or a product of the roots. So now we can substitute in the values that we know, which is 5/3 for the sum. For the product, it was 2/3. For the sum again is 5/3. And then all of that over the product, which is 2/3 cubed. If this was a non-calculator paper, we'd have to then do a little bit of numerical work to work this out. But when you do that, you get a final answer of 35/4 for the value of this without having to work out what the roots actually are. So these are some examples of how you might manipulate some algebraic expressions and use the rules for the sum and product of the roots of a quadratic.